Hello everyone, and welcome to another Hackolate tutorial. In this episode, we're going to be talking to you about how you can use Hackolate to infer primary keys and foreign key relationships in data models that do not necessarily already have that information in them. Right? This can be really useful, right? Because not always are these types of keys and relationships constraints present, right? Sometimes you just happen to have loaded the data model from a source that did not have these constraints. Or sometimes the source, the big data analytics platform, for example, like Synapse or Snowflake or whatever it might be, does not necessarily support such constraints, right? And you therefore reverse engineer your model from that target without those constraints. Or in many other situations, you may have had the capability to have constraints, but you decided not to enforce them, right? Because obviously enforcing PKs and FKs has performance implications. Right? So for documentation purposes and for modeling purposes, we obviously do still want to know about these relationships and want to know about these PKs and FKs, right? So what we are offering in Hackolate is the availability of a feature that allows you to reconstruct and identify these types of relationships and constraints using a two-phased approach, right? It's important to understand that this approach is based on academic work, right, by Jan Mottel and Pavel Kordik, but this is all based on model metadata. For example, it's not based on query logs and stuff like that. So if the metadata is inconsistent, then you may or may not get great results with this approach. So the methodology that we're using here has two phases, right? The first phase, or the first stage, is when we identify the primary keys of your entities, right? Why? Because then, when we, in the second phase, identify the foreign keys, and therefore the relationships, the constraints that go with that, we can actually leverage those PKs that have already been identified, right? Primary key identification helps us with foreign key identification. So in each stage, the model and the method will predict a probability that an attribute is actually part of a constraint. And this probability is then passed to an optimizer to give us a prediction, right? So in the first phase, we'll be using a number of attributes or indicators for primary keys, right? So the attribute position in the table, the data type, right? The keyword that is in the attribute name, the similarity of the attribute name with the entity name, right? And to do this, we actually use a really interesting capability of calculating the string distance, which is a measure of how different two sets of strings are from one another. Then we also use the nullability, you know, is it possible to be null, yes or no, and the attribute width, right? So how many bytes are in that attribute. Then when we have that, when we have these attributes, when we have these indicators, we will go through a logistic regression to estimate the probability that an attribute is actually a primary key, yes or no, right? And then the ones with the highest probability are going to be declared to be a primary key, right? Possibly there might be more than one, and in that case we will create a composite key. In the second stage, we'll be identifying the foreign key relationships, right? And you know, here's how we do that, right? We have a number of indicators for that as well, right? Whether or not they are a primary key, the data types, the data type properties, the similarity of the names again, right? So the distance, the string distance that we can calculate. Whether or not these foreign keys have a similar width, right? The attribute width, minimum, maximum values, all of these types of indicators are used to identify the foreign keys. And again, logistic regression is going to estimate the probabilities, and the most likely foreign key constraints are going to be returned. We should mention, obviously, that this is a best effort function. You know, success is not guaranteed. It depends on many factors, and for one data model it might work great, and for another data model it might not work so well, right? So please understand that and handle this with care. And then with that, I'm going to switch over to a short demonstration of how this capability works in the Hackolate Studio. So here we go. Here we have a data model for a Synapse database, right, which is a Microsoft product for big data analytics. And in this data model, I have a long list of different entities, right? I have sales, I have promotions, I have resellers, I have all of this information in this data model, right? But you may have already noticed, you know, especially if I zoom out a little bit, you know, there are no relationships in here, right? So 0 relationships, right? So this is a characteristic that you find, you know, for a variety of different reasons, and this is a perfect possibility for us to apply this inferencing technique, right? So what I'm going to do here is I'm going to switch to the Infer PKs and FKs capability here. It will ask me to select where to apply this to, right? Which schema and which tables to apply this to. And once I do that, the first stage, as we already explained, is going to allow me to select the primary keys, right? Oh, guess what? You know, I've now found a number of primary keys. And then in the second phase, it's going to allow me to select a number of FK relationships, right? When I do that, and I accept all of the choices, you will already have seen that there's a long list of new relationships that have been added, right? Let's just quickly reorganize this, and you will see it much more clearly then, right, that this is now a much more richer data model with a lot more links between the different entities, and this obviously would be useful for us to include in our modeling and documentation efforts. Great. With that, I'm going to wrap up this short tutorial again, point you to some of our documentation so that you have the latest and greatest information at your fingertips. And thank you for paying attention, and wish you a wonderful rest of your day. Have a good one.